Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by my co-host, Victor. Before we dive in, I'd like to remind our listeners that if you're enjoying our content, please rate and review us on your preferred podcast platform. It really helps us reach more developers like you.
That's right, Sheila. Your support means the world to us. Now let's jump into today's topic. We're continuing our journey through Chapter 5, Networking in P2P Systems, and we'll be discussing the ICE framework.
Absolutely, Victor. But before we get into the nitty-gritty, I've got a quiz question for our listeners. Here it is. In which popular communication application is the ICE framework commonly used?
Oh, that's an intriguing question, Sheila. It really makes you think about the technologies we use every day without even realizing it. I'm sure our listeners are racking their brains trying to figure it out. Let's break it down a bit without giving away the answer. We're talking about a communication app that needs to establish peer-to-peer connections, possibly for voice or video calls. It's exciting to consider how many apps might be using ICE behind the scenes.
Great point, Victor. Now, before we dive deeper into ICE, could you give us a quick refresher on what NAT is? I think it's crucial for understanding the context of ICE.
Certainly. NAT stands for Network Address Translation. Think of it as a traffic director for your home network. It allows multiple devices in your home to share a single public IP address. While NAT is great for conserving IP addresses and providing some security, it can make it tricky for devices behind different NATs to chat directly with each other.
Thanks for that explanation, Victor. So, given that NAT can cause issues with direct communication, I'm guessing that's where ICE comes in. Can you tell us what ICE stands for and give us a basic overview of what it does?
Absolutely. ICE stands for Interactive Connectivity Establishment. It's like a friendly mediator that helps devices connect with each other, even when they're behind NATs or firewalls. Essentially, ICE is like a Swiss Army knife for making connections. It tries various methods to find the best way for devices to talk to each other.
That's a great analogy, Victor. So, if I understand correctly, ICE builds upon the stun and turn protocols we discussed in previous episodes. How does it combine these technologies?
You're spot on, Sheila. ICE cleverly utilizes both stun and turn. First, it tries to use stun to discover the public address of a device. If that doesn't work, it falls back to turn as a relay. But ICE goes beyond just using these protocols. It creates a structured process for finding and testing different connection methods.
That sounds really useful. Can you walk us through the basic steps of how ICE works?
Of course. The ICE process can be broken down into two main phases: gathering candidates and performing connectivity checks. In the first phase, ICE gathers different types of candidates. These are potential addresses that could be used for communication. There are three types of candidates. Point 1, host candidates, local addresses on the device. Point 2, server reflexive candidates, the public address as seen by a stun server. 3, relayed candidates, addresses on turn servers. Once candidates are gathered, ICE moves to the connectivity check phase. It pairs candidates from both devices and systematically tests these pairs to see which ones can establish a connection.
Wow, that's quite a process. It seems like ICE is really thorough in its approach. But I'm curious, how does it decide which connection to use if multiple options work?
Great question, Sheila. ICE uses a priority system to rank the candidate pairs. Generally, it prefers more direct connections over relayed ones. So, a direct peer-to-peer connection would be preferred over a connection that needs to go through a middleman server. ICE will typically choose the highest priority pair that successfully establishes a connection.
That makes sense. It's always better to have a direct connection if possible. Now I can see how this would be really useful for applications that need peer-to-peer connections. Can you give us some examples of where ICE is commonly used in the real world?
Absolutely. ICE is widely used in WebRTC applications. This includes many popular video conferencing tools, voice chat applications, and even some online gaming platforms. Basically, any application that needs to establish direct connections between users, especially for real-time communication, can benefit from using ice.
That's fascinating. It really puts into perspective how much we rely on technologies like ice without even realizing it. Are there any common misunderstandings or pitfalls that developers should be aware of when working with ice?
Great point, Sheila. One common misunderstanding is that ice guarantees a connection in all scenarios. While ice is very effective, there can still be network setups where it's unable to establish a direct connection. In these cases, falling back to a relay server is crucial. Another pitfall is underestimating the time ice might take to establish a connection. The process of gathering candidates and performing connectivity checks can take several seconds. Developers need to account for this in their application design and provide appropriate feedback to users during this process.
Those are really important points, Victor. It sounds like patience and proper fallback mechanisms are key when working with ice. Do you have any tips or best practices for developers implementing ice in their applications?
Absolutely. Here are a few key tips. Point 1. Always implement a turn fallback. While it's less efficient, it ensures connectivity in the widest range of network scenarios. Point 2. Use ice restarts when network conditions change, like when a mobile device switches from Wi-Fi to cellular data. 3. Implement proper timeout handling. If ice takes too long, you might want to retry or fall back to an alternative method. Point 4. Consider using trickle ice, an optimization that allows candidates to be sent as they're discovered, rather than waiting for all candidates before starting connectivity checks.
Those are great tips, Victor. Now, before we wrap up, I think it's time to reveal the answer to our quiz question. The question was, in which popular communication application is the ICE framework commonly used?
Ah yes, the moment of truth. While ice is used in many applications, one very popular example is Skype. Skype uses ice as part of its process for setting up voice and video calls between users.
Thanks, Victor. I hope our listeners found that interesting. To summarize today's episode, point 1, ICE, Interactive Connectivity Establishment, is a framework for establishing connections between devices, even through NATs and firewalls. 2. It combines stun and turn protocols, gathering various types of candidates for potential connections. 3. ICE performs systematic connectivity checks to find the best available connection. 4. It's widely used in WebRTC applications and real-time communication tools. Point 5. While very effective, ICE isn't guaranteed to work in all scenarios, so proper fallback mechanisms are important. Victor, do you have any final thoughts before we sign off?
Just that ice is a crucial technology in our increasingly connected world. It's a great example of how clever engineering can overcome complex networking challenges. I encourage our listeners to explore ice further, especially if they're working on any peer-to-peer or real-time communication applications.
Excellent point, Victor. And to our listeners, remember to visit crashcasts.com and join our Discord community to continue the conversation. If you're finding value in our content, please consider supporting us on Patreon. Every bit helps us create more in-depth content like this. Until next time, happy coding.